Troubleshooting steps and procedures. Identify the problem. Recognizing the issue is the first step in troubleshooting. This involves observing the network's behavior and noting any performance degradation or failures, similar to identifying symptoms when you feel unwell. Identify symptoms. Symptoms are the observable signs of network issues, such as slow connectivity or dropped connections, and they provide clues to the underlying problems, akin to a car making strange noises indicating potential issues. Determine whether anything has changed. Networks are sensitive to change. Determining whether a recent configuration change or update has occurred can often explain new issues, much like identifying a new ingredient in a recipe that might have altered the taste. Duplicate the problem if possible. Replicating the problem can confirm its existence and provide insight into its nature. This is similar to replaying a scenario that led to a mistake to understand how it happened. Approach multiple problems individually. When faced with multiple issues, tackle them one at a time to avoid confusion and ensure each problem is resolved thoroughly. Similar to handling tasks on a to-do list individually. Establish a theory of probable cause. Formulating a hypothesis about the cause of the network issue is a critical step. This theory guides the troubleshooting process, akin to forming a theory in a scientific experiment based on observed phenomena. Test the theory to determine the cause. Testing the theory involves conducting specific checks to validate if the supposed cause is the real issue, similar to testing a scientific hypothesis through experimentation. Establish a plan of action. Once the cause is identified, a plan of action is formulated to resolve the issue. This includes steps to mitigate or fix the problem, similar to creating a project plan before starting work. Implement the solution or escalate. Implementing the solution involves executing the planned steps to resolve the issue. If the problem is beyond your capability, escalating it to higher level support is necessary. Much like referring a complex legal matter to a specialized attorney. Determine whether escalation is necessary. Deciding on escalation involves evaluating whether the issue requires additional expertise or resources, akin to deciding whether to visit a specialist for a health concern. Verify full system functionality. Post-resolution, verifying that the system is fully operational and that the solution has not introduced new issues is crucial, similar to testing all the functions of a device after repair. Document findings, actions, outcomes, and lessons. Comprehensive documentation of the troubleshooting process, actions taken, outcomes, and lessons learned is essential for future reference, akin to writing a detailed report after completing a project. Network engineer training. Importance of troubleshooting steps and procedures in network engineering. Troubleshooting is a critical process in network engineering, providing a structured approach to identifying, diagnosing, and resolving network issues. It begins with identifying the problem, akin to noting symptoms of illness, followed by pinpointing specific symptoms that the network exhibits, such as slow connectivity or dropped connections. Understanding what has changed in the network environment is crucial, as even small modifications can have significant impacts. Duplicating the problem helps in confirming its existence and understanding its nature. much like replaying a scenario to understand a mistake. When facing multiple issues, it's important to approach multiple problems individually to avoid confusion and ensure thorough resolution, similar to tackling tasks on a to-do list one at a time. Developing a theory of probable cause is like forming a hypothesis in a scientific experiment, guiding further troubleshooting efforts. Testing the theory then involves specific checks or procedures to confirm the cause, leading to establishing a clear plan of action to resolve the issue, much like creating a project plan. Implementing the solution or deciding to escalate the issue is a crucial decision point, determining the direct handling or need for additional expertise. Understanding when and how to escalate is vital, akin to knowing when a specialist's input is needed. After implementing a solution, it's important to verify full system functionality to ensure the problem is fully resolved and no new issues have arisen. Lastly, documenting findings, actions, outcomes, and lessons learned is an essential step for future reference and continuous improvement, similar to writing a detailed project report. This documentation serves as a valuable resource for future